Sorry. So in this new video of mine, I'm gonna teach you exact differential equations. That is the first order. So a differential equation is said to be exact if its left hand side or right hand side is exactly the differential of some function. So for examples, how to get what this means or this whole text, what it means, I'm gonna treat one, two, and the third. You're gonna like try to see your skills, because if you're able to pull over this third equation, then you're good to go. So let's dig in. So for the first one, we're gonna write solution, and we're moving. So say 1y plus x to 1 dx equals to x cubed. So just for the notice, I want you to know d1 dx is equal to y prime. So if you see me write y prime, you should know I like the long stuff. So what we're gonna do is, like, when you see these two, you notice the main equation that was like differentiated was xy, because when you differentiate, you keep y constant, differentiate x, you get y, and you keep x constant and differentiate y, you get d1 dx, which is y prime. So what you want to do is put it in this form. So we mostly deal with observation. So for this part, you gotta be very observative. So like, I was able to observe that if you like keep x constant, y constant, and differentiate x, you will get y, and keep x constant and differentiate y, you get y prime. So it's just a key, so equals to x cubed. So rest assured, this and this are the same. You can try. So the next step I want to do is implies. If I take this man this way, somehow we got t equal to x cubed dx. So you might want to integrate to like take off the d. So integrate both sides. How. So if you integrate this and this go off to xy equal to like x or 4 and 4. This k and y equals to, like, take this one this way. Take it this way, you have x equal 4x plus k and 4. If you want, you can put equal to x apart 3 and 4. Sorry, x plus k and x. So this is what you get. So this is what you've been looking for the first one. So for the second one, second example, we're gonna do something very similar. We'll just say 3x y prime. So this is the same as d1 to x, so you shouldn't be confused why you're seeing that. You got e part 3x equals to x. So you might want to observe that here we got normally just e to the power 3x, and we got a y prime. It means the relation has gone as occurred, and no constant in front of the e to 3x implies y wasn't to any power greater than 1. So say y was to the power 1, so we get y prime. And now we got plus, and we got 3y. Then this man has left and come here, like when differentiate e, you got like the constant differentiate function all over and get all down. So we got 3y to the power x. So from this version, I'll say this gives me y e power 3x. It could verify. I thought it could verify. I'll go into here differentiation. So you got to know the basics for start something. So put equal to x and move on. So as I was saying, I wouldn't go on teaching you differentiation. You have to know it for trying to solve differential equation. So it's basically what you gotta observe. So you gotta very observative, keen, know how to differentiate certain functions that would help you very importantly in differential equation. So I'm ahead on. So I'll do same. I take this one this way implies you got d of y e to the 3x equal to x dy dx, sorry. So we'll do the same thing, integrate, take up the d, so you got y e to the power 3x equal to x squared until, don't forget the constant of this of integration, because ain't got no limits. No 0 to 2, no 2 to 0, no a to b. So you gotta put this case, very important, to take off any constant that arises when you solve. So got us on the integration. I don't need to teach you that. So got y equal to, like, take this one this way, share this way, we got x squared over 2e to the power 3x plus k over e to the power 3x, which is plus y equals like x squared e to the power negative. See, the negative appears when you like take the e up, so you gotta put negative over 2 and you get plus k into like negative. So there we go. So as I was saying, I'm gonna let you solve this number 3, because if you're able to pull up with it, you will like be able to test yourself on what you can do. So I might give you, like, I don't know, you could pause the video and go solve it and come back. But for teasers, I'm just gonna leave the answer for question number 3. So we got question number 3. Answer. Okay, Lord, it's coming, right? Getting surprise back. Okay, so it will be y equals to plus minus square root of 16 silver plus cube x. So this is what you should get if you solve it quite great. So we'll be moving down to the integration factor. So integration factor. I'll be right back. Just give me some minutes. I wanna freshen up, kind of thirsty, hungry. I was a lot to eat before solving. It's required in school, so I'm coming back. Okay, so I'm back from my break. We're gonna be talking about the integrating factor, the IA. So this is given the first order differential equation here. We're gonna be using it to work. So when someone's giving you an equation, first differential equation is given to you in this form. First order. Remember, we call it first order because it's the first derivative of x. So d1 x is the first derivative. So call it first order. So now, suppose the left hand side, which is made up of this, it's not a full function of x, so we will try to make it a full function of x by multiplying by another function of x. So we completely show is function of x. So that other function of f that we use to multiply this main function is what I call the integrating factor. So I want to suppose my integrating factor is I of x. So I of x will be equal to you got e to the power p dx. And don't think the p we're talking about is not a p or space p maniac p, but it's nothing else but this p. So the p we're talking about is p. This is the same p we're talking about here. So we'll dig in with some. I'll give like 3 examples and I'll solve 2. Or you solve a third. You can like if you got some problems and you don't understand some steps, you could drop it down in the comment and don't forget to subscribe. It's very important for me. I want to teaching you more and any other stuff you can like post in the comment that you want this video and I'll see if I can wrap it up for you and make you get clearer. So let me give you an example. So we got examples. So as I said, I'll do the first 2 and you do the next 3. So find if by that I mean integrating factor for following DEs and solve them. So number 1 we got x dy and dx plus 4y equal x. Okay, so we'll go to here now. Second one, okay, tan x dy on dx plus y equals to sin x. And the third one we got y prime plus y equal x. Okay, so here we say when x equals 0, y equal 1 in bracket. So here when x equals 0, y equal 2, so equally we're gonna solve for the equation. So let's go ahead with the solutions. So for number 1, so it's x dy dx plus 4y equal x. So what I want to do is eliminate this x because in the original equation you see the dy had no coefficient, so you got to make it empty. So we're going to do it by dividing through by x. So we got dy dx plus 4x and y equal to 1. So now where's our p? This is our p. Remember here, p is the coefficient of y. So for integrating factor, it would imply I of x equals to e p dx. So just gonna write p equals to 4x equals to e 4 on x dx. So equals to e to the power ln 4 ln x. Pause. So equal to e ln x to the power 4 equal to x to the power 4. So it would imply we multiply the whole equation by 4 dy dx plus 4x cubed y equal to x to the power 4. Okay, so now we gotta use our observation. We've got x to the power 4 dx, dy dx plus 4x cubed y. So by observation, you gotta be very good at observing. I can see how like y x to the power 4, because when you keep x to the power 4 constant and differentiate y, you get dy dx, and keep y constant, you get d. So we're good to go. dx equals to x to the power 4. It would imply we got d of y x to the power 4 equals to x to the power 4 dx. So integrate this. We learned in the recent video, so integrate what we get is y x to the power 4 equal to x to the power 5 and 5 plus k implies y equals to like share this one this way, share this way, so we got x and 5 plus kx to the power -4. So this is what you get. This is the equation that we've walked through and we got what we wanted. So we're gonna dive into number 2, tan x dy plus y equals tan x. So number 2 says tan x dy on dx plus y equals tan x. And when x equals 0. So let's solve. So remember what we gotta do? We gotta make this man single, you understand? We gotta make him single at all costs. It's a muscle. We got dy on dx plus cos x over sin x in the y. So notice this is just cut x 1 over tan x, so it's no new something. You gotta just simple basics. I don't. Okay, so okay, let me just write it. Okay, sin x which is the same as dy dx plus tan x into y equals to tan x times so y from dy and dx plus cos x over sin x, or in the y equal to cos x. So I of x equal e equal x over sin x. So it's important to put your p aside, so you usually fit it in the equation. You got p dx equal to e. Okay, you can put cos x over sin x and you get dxy. So that's a way to do it. Equals to e or yeah. So to break it down, you have differentiate this man. You have integrate sin x over sin x and lean over sin x. Is what you get. So it's equal to e lean of sin x. So just wanted to show you what you get when you do it correctly. So equals to sin x. So this is a integrating factor. We're going to go multiply back to the normal man or the regional man, anyone you want. So I'm going to choose this one. So we got sin x d1 dx plus, so if you put like sin x into cos x, sin x y equals sin x times cos x. So you get dy on sin x, dy on dx. So these cancel out. You got plus cos y cos x equal to sin x cos x. Okay. So we continue. Want to make y subject, so we got first of all, we gotta observe. So here, I think it will be d y equals x. Reason dx. Reason being that there are no negative signs, and when you differentiate the sign from the okay, sine x, sine x, sine x. So I'm gonna cancel that. Okay, reason being that there's no negative sign, because if it was a negative sign, it means it'll be cos x, because when differentiate cos x is negative sine x, everything's plus, and so it's okay. So if you want to verify, both the same, yeah, sine x, cos x. So if you keep sine x constant and differentiate y, you get sine x y prime, and you keep y, you get y cos x. So it's good. So you gotta be keen at observative. So it's very simple way to go. It's equal to this, but this man is equal to half sine 2x. It means for basic trigonometry, go verify this the both equal. So we could say the greatest man. Great. This man, okay, no, not yet, so I'll say. So we can now integrate. Okay, so we have y sine x equal to differentiate, you get y plus half interact negative cos 2x equals. Okay, I love to use k as my constant of integration, so I have y sine x equals to 1/4 cos 2x plus k. So we're good so far, so go. Okay, so y like this minus way, but we won't do that. They said when x equals 0, y equals 1. So we're gonna try and look for the value of k. It's okay, so we get sine 0 is 0, so 1 in equals negative 1/4 cos 0 plus k, so plus k equals 1/4. K equal 1/4, so we done it, we did it. So we can just say this implies y sine x equals to 8/4 cos 2x plus 1/4. So we get k equal 1/4 when we press it. It takes one way. Plus we got this, so we could divide by sine x on by power of y equals to. Take this out. We got 1/4 in x. And this is what we want. So please subscribe. Don't forget to click the alarm button to get more videos. So see you next time. I'm glad and I hope you love it. Any problem you get doing the setup, the work, you might want to comment, drop it down. Any problem you want. I got some notes on DE, so if you want I can give you, we could go further. Thanks. So